Energy from Technological Institute of the Philippines and Exora Technologies Incorporated. The first one, Technological Institute of the Philippines.
Have you ever heard of a clean source of energy that could also clean the environment? Ladies and gentlemen, today I will be presenting to you our technology, a TRL5 technology, the Ilawa. It is an aluminum air battery that produces electrical energy while it is exposed to the open water. And when you say open water, you can probably think of the sea or the lake. In our laboratory experiments of our prototype, we have established that as the battery produces energy or harvest energy, it also remediates more of the phosphate pollution that is in the water. And indeed, as part of our journey, our very first prototype, the photograph of which is in our exhibit at the back, was actually presented to a competition known as the CCAT Challenge, which we won. And we tested the prototype in Laguna Lake. And we all know how polluted Laguna Lake is, especially with phosphates. And phosphates is the major cause of eutrophication, which induces fish kills. And so if the battery is exposed to the water in Laguna Lake, it actually helps clean up those phosphates. So we started with the CCAT Challenge way back in 2017. The grand prize allowed us some seed money to be able to develop our prototype. And the year after that, we were lucky that the DOST-STII granted us TECHNICOM funding, which allowed us to further develop a semi-commercial prototype. And this year, we also got our first patent for that technology. So in order to move forward, our push for commercialization is actually addressing the aspects of scalability as well as affordability. And when we say affordability, our push is really to miniaturize, make it light enough so that it produces enough power, while we can scale it up so that it will generate enough power that will be able to help fishermen or touring vessels in the sea or in the lake. So to move further, we actually need partners among suppliers. So part of our part of the component of the technology is activated carbon. And right now we source our activated carbon from water filters, the ones that can be bought at hardware stores. So that's not cheap. And we also need to partner with people who fabricate using plastic, because right now the enclosure of the cells that we are using are 3D printed, and that's not cheap as well. So in order to produce it in the mass numbers, we should be able to fabricate it using plastic injection molding. And also, we realized from our market research that aluminum recycling here in the Philippines is not consolidated. Now, a major component of our technology is also aluminum, and we would like to partner with somebody who is big enough to provide us with recycled aluminum. So in the next 5 years, we actually plan to deploy this technology to help fishermen be able to power their DC freezers so that they can keep their catch fresh while they are traveling from the open water back to the shore. And so with this technology, which only generates electricity by being exposed to the sea, we should be able to provide clean source of power while we are also helping people recycle aluminum. And also, we also look into the possibility of powering chargers. So we have been lucky to get the interest of the Philippine military. And right now their problem is that while they are in the field, they don't have a reliable source of power that they could use to charge their mobile phones. And you know, mobile phones these days for the military is a very useful communication tool for coordination. And that's it. Thank you very much for listening.
Thank you very much. That's Technological Institute of the Philippines.